gets too cold, you'll freeze the solutions. And
does it happen on the way up?
And then, yeah, you know how it gets colder as you get into the stratosphere, and then it starts warming up. So you play this balance between not freezing the solutions and not boiling them off.
So this is warm enough to keep them warm from the cold part?
Yeah, the pump running and the battery discharging in there keeps it somewhat warm. And when it's really cold in the winter, start doing other things to try to keep it warm, like a little heater inside, or these little packets of water heated up. Let's just stick it in there for warmth.
Is it much colder the higher you go into the ozone?
What happens is you start out here at minus 30 or something, and then there's an inversion in the first 1,500 feet or so, maybe, so it'll get warmer.
Yeah.
And then it starts getting cold, and as you get up to around, into the middle of the stratosphere, 20, 25 kilometers, you'll get the coldest part, and then it starts getting warmer as you get out.
How cold does it get up there?
In the winter, it can get to about minus 90 Celsius at the coldest. Right now, it's not getting all that cold.
And the equipment can handle it? Wow.
I mean, you know, we have the foam box, so it's insulated, and we don't want to get too cold in there. The little electrochemical cell can freeze, you know, if it got too cold. So try to keep the temperature in the box reasonable. Do you have a temperature profile?
That's from the balloons on the balloons today.
That's the most interesting plot because this is the abundance of ozone, and this is your altitude. So going up here, you know, you're getting into the stratosphere about 10, 12 kilometers on up. So that's where all the ozone normally is.
Right.
The interesting thing, the blue plot is from South Pole back 1967 to 1971. People were studying ozone just for the sake of studying ozone. And so they did it, and they figured they learned everything they needed to know about ozone. They never did it again. Then in the 80s, they started figuring out that there was an ozone hole, and this would be October 2001, the red plot, and you can see where, you know, between about 13 to 20 kilometers, there's no ozone. And this one's 1986, when they first started, you know, deciding there was an ozone hole, so you can see some depletion.
So it looks like the hole's pretty solid, you know, at a certain altitude.
Right, and that's
normal. Then it's changing.
This is where the chemistry occurs that destroys ozone, especially with the polar stratospheric clouds when it gets really cold.
Right.
So you know, this is just that section where the sun's hitting, and you get the depletion, the catalytic reactions that go on.
And where is that in the stratosphere? Is that like near the troposphere, like that?
The tropopause?
Yeah.
That would be about 12 kilometers or so is where that would be. So you're in the troposphere up to about here, then you get into the stratosphere, and then once you get out into here, you're headed toward outer space.
I heard the tropopause is getting smaller. Is that true?
Lower or higher? Oh, I don't know.
Yeah, I guess higher. Yeah.
Higher? I'm not sure. That'd be interesting to see. I got to put this back to.
The old ozone is old ozone data an average for those years?
Yeah.
And why was it? It was a maximum. You don't have to put it back.
It's This was, and it's what it sort of is what it would look like now, you know, this time of year. Now that the ozone hole is, the polar vortex is broken up, and the ozone from the higher latitudes or lower latitudes will fill in, and then you have regular ozone profile, which looks like this, where we have that really high ozone in the stratosphere, and that's what. This is October to September, October average for 67 to 1971. So that's saying that's what it ought to be during that time that we now have all the depletion. Sometimes our balloon program crashes when we go out for a while. It's a DOS program.
So how'd you get interested in ozone?
How did I get interested? I guess I went to college for chemistry, and I was at the University of Colorado, and I answered an ad in the paper for a job, and that's how it started.
Come out here?
No, not to come here. I was just to work in Boulder in a lab.
Oh, okay.
And then it wasn't very long after that I started coming. Actually, I started going to Greenland first.
Were you doing the air quality stuff that they do over in Boulder? To collect all the samples from all over the world? No.
Yeah, I was in a lab analyzing these air samples from all over the world. That's how I started.
There was this tractor just going by. And we have also wind changes that goes that way.
I think it needs to go pretty far that way, like past the outfall.
Okay, I'll try and figure it out further.
Because it's definitely kills the signal.
Does it totally mask it?
Like ozone, yeah, the carbon goes in and it changes the current. So we're trying to get a good surface measurement, and you need clean air, and we're on the downwind side of the whole station.
So why doesn't all that ozone on the surface go up to the stratosphere?
Yeah.
It's killing us down there.
It's a pollution down at where we are here. Yeah, and it's so, ozone's so reactive that, there's no ozone in this room right now. Okay. If you wanted to check it, because any ozone that gets in here just reacts with something right away and it's gone. Oh. And so that's what it does in the troposphere. Okay. And the ozone that's in the ozone layer in the stratosphere is created there.
Okay.
By the UV light hitting oxygen molecules, breaks them apart, and then you get O3 and you get oxygen, molecular oxygen, and you got these reactions that are going round and round all the time because of the UV light. But see, the ozone depletion, so that should just be sort of in an equilibrium. Okay. But then if you add chlorine